Hello students, so let us try to solve this particular problem where we have to calculate the spectral term for the bromine plus for a LS coupling scheme, and it is given that the atomic number of bromine is 35. So, what we have to do? We have to calculate the lowest energy of spectral term for the bromine plus. So, let us try to go for first what is the atomic configuration of bromine, electronic configuration of bromine. So, we have bromine is nothing argon as well as 4s2 3d10 and we have 4p5. And what will happen to bromine plus? Bromine plus is argon 4s2 3d10 and we have 4p4. So, what will happen in the optical electron? You can see this is your optical electron and this is equivalent because we have same value of L and same value of N is there for all four. But calculating P4, the spectral notation of P4 is little bit tough, but we know that the spectral notation of 4P2 and 4P4 is exactly same. So, we know all this property for the equivalent notation. So, what we will do? We will calculate for P2. So, for the P2, what we have? L1 is equal to 1 and L2 is equal to 1. And from there, L value is equal to 0, 1, 2, that is your capital L. And similarly, we have S1 is equal to half and S2 is equal to half. So, here we have S is equal to 0 and 1. But when we have equivalent electron, we have to go for the Brit scheme. In the Brit scheme, what we will do? We will write the configuration, write the all composition for the magnetic moment, the combined magnetic moment. So, what are these particular magnetic moment? So, for L is equal to 2, the ML is equal to -2, -1, 0, 1 and 2. And for L is equal to 1, ML is equal to -1, 0, 1 and for L is equal to 0. So, ML is equal to 0 and we know this ML will come due to your same value of L, same value of ML, ML1 and ML2 will be same. So, this will be, we have same value of ML1 and ML2. So, that means spin Z component of spin should be different. So, what will happen? This must be your singlet state, and similarly on the same logic in the Brit scheme this will be from the diagonal. So, this value is also is equal to 0. So, these two have singlet state and obviously this will be your triplet state. So, obviously, we know that among the singlet and triplet state, what will happen? The triplet state will have lower value of energy. So, that we all know. So, what will happen? So, let us try to go for this one. So, once we will go for L is equal to 1 and S is equal to 1. So, we have to calculate L is equal to 1 and S is equal to 1. Will have the lower energy. And what is value of J? So, from here J is equal to 0, 1 and 2. So, what will happen? So, we have a spectral term S is equal to 1, that is 3 P0, 1 and 2 is there. And now, for the P2, 3 P0 is the lowest energy, but we have to calculate for P4 and here P4 is the more than half filled. So, here will be the inverted splitting is there. So, what will happen? We have the lower value of energy is 3 P2 will we have lower value of energy because we have to calculate for P4. So, P4 have always inverted value of this particular splitting. So, this will be your correct option. So, students, from this question you can just completely revise the spectral notation of equivalent electrons and you can just solve it very easily. Okay? Thank you.